Okay, one of the things you need to remember is that if your R is positive, if your correlation is positive, you're going to have, it's a slope that's going to be increasing, and if your R is negative, you're going to have a slope that's going to be decreasing. So again, what this is telling you is that you have, oops, hold on. So basically, if you read here, positive R indicates a positive association, all right? And negative R represents a negative association. Your correlation always falls between 1 and negative 1. All right? Correlation always falls between 1 and negative 1. So that's this part right here. All right? So it always falls between 1 and negative 1. Now, all right? Now, another thing you have to look at is this right here. Look at the scatter plot. If your scatter plot has all right, so if you look at this, if you notice, it's all over the place. So there's really no correlation whatsoever. And again here, there's slight correlation, very, very slight correlation. So if I draw a line here, it's very slight. There's some consistency from this side and from this side. So that's why it's at negative 0.3. Now this one is a little bit more consistent. So the little bit more dots are closer to the line. So therefore that's why it's in a correlation of 0.5. Here it gets a little stronger. It's negative, but the lines are still spread out. There's still some variance, but they're closer to the line. This one, it's real close, so that's why it's a correlation of 0.9. It's still positive. And this one is almost a straight line, and that's negative 0.99. All right, one of the things you want to do, if you want to practice your skill on correlation and guessing correlation, go to www.stat.uiuc.edu/courses/stat100/CUWU/games.html. All right, one of the things you got to remember, because R standardizes the scores, correlation does not change. All right, so correlation does not change when we change the unit of measurement. So as it's reading right here, of X and Y or both, measuring weight in kilograms rather than pounds would not change the correlation of 0.795. Okay, basically the correlation ignores the distinction between explanatory and responsive variables. In other words, you can swap them. So like right here, it doesn't matter which one I put first, whether I put Y first or X first. This is a multiplication. Since this is multiplication, it doesn't matter if it's X times Y or Y times X. It's still going to get the same thing. Okay, we talked about this. Correlation measures the strength of only straight line associations. So if you have a curve or if you have a parabola, it's not going to measure the strength of there. It only measures straight line associations. Okay? Okay. Just like mean and standard deviation, the correlation is also strongly affected by a few outliers. So remember, if you have this right here, and this is a strong positive correlation, if you have one that's down here, what it's going to do is it's going to decrease, it's going to weaken your correlation, all right? Just like the average and standard deviation. Another thing you might want to think about is ask yourself, what happens if I remove that point? All right, so if I have all this data, and then I have this I have this one point here that doesn't fall in line, all right, basically that's going to reduce my correlation. Let's say that brings it down to about 0.70, all right? What happens if I remove that? What happens to my correlation? All right, it's more in a straight line, so does my correlation go up or down? In this case, it's going to strengthen my correlation. Let's say maybe 0.95. Okay? Okay, remember on this graph, this line right here is actually your X bar line. And this line right here is actually your Y bar line. All right, in the middle here, wherever these meet, that's the coordinate point, X bar, comma, Y bar. And remember, your line of best fit always goes through that point. Okay, so whether you use the y-intercept or in this case, whatever that is right there on this graph, you're going to use those 2 points. Okay.